This video is going to show how to factor the GCF. This is the first thing you do when you're factoring quadratics every single time. You're going to find the GCF. Now we're going to start with just finding the GCF of the terms, not factoring them, just finding the greatest common factor, what they have in common. So we look for, remember the GCF is the biggest number and or letter that each term can be divided by. Number 1 only has 2 terms. It's a 12 and an 18. It only has numbers, so we have to find the largest number that goes into both 12 and 18. One way you can do this is actually writing out all the factors of 12 and 18. So I'll start with 12. I always go in order. I do 1 times 12. You can also have 2 times 6 and 3 times 4. These are all the factors that will multiply to 12. Then we go to 18. Start with 1 times 18, 2 times 9, 3 times 6. And those are all that you have, because once we get back to 6, it will just go back to 3. I do this in this order so it goes least to greatest. Now I find the biggest number that's common to both of these. So if I start up here, 12. 12 is the largest one on 12, but it's not in 18, so I can't use it. 6 is the next one in 12, and 6 is in 18, so it's the largest one in both 12 and 18. So therefore, your GCF for 12 and 18 would be 6. So we'll say GCF equals 6. That's the first step. Then we're going to actually factor it later. So let's try 10x and 25x cubed. This has both numbers and letters. Again, there's only 2 terms, numbers and letters. So we look for the numbers first. So if we have 10x, the factors of 10 are 1 times 10 and 2 times 5. Then we look at 25x cubed. 25 is 1 times 25 and then 5 times 5. They have to be integers. They can't be 2 times 12.5. That wouldn't work. We need integers. So I look at, start over here, 10. 10 is the largest one on 10, but it's not in 25. The next one would be 5. 5 and 5 do work. So GCF right now is 5. That's the number. But because they both have a letter, we have to check if they're the same letters. This is x and this is x cubed. That means that they both do include an x. That means that each of these can be divided by an x. The easiest way to look at this is you actually look for the smaller of the exponents. X to the first. I can divide each of these by x to the first. I cannot divide both of these by x cubed because I only have one here. So my GCF for the letters would just be 1x. I only have 1x for this one. So the GCF would be 5x. You need to make sure that it is the entire 5x. Now if we try this one, we're going to do the same thing. So focus on the numbers. The numbers are the harder ones because you actually have to figure out the values of them. So I'll start with 48 x squared y z to the third. Start with 48 is 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 does not go into 48, 6 does, 6 times 8, 7 does not, and then 8 just repeats. Then we'll go to 72 x squared y squared z squared w. So the factors of 72 are 1 times 72, 2 times 36, 4 times, 72 divided by 4 is 18. 72 divided by 3, 3 times 24, 4 times 18. 72 is not divisible by 5. 72 divided by 6 is 12. 72 is not divisible by 7. 72 is divisible by 8, so it's 8 and 9. 8 times 9. So I'm going to look over here at the 48. 48 is my largest one here, but it's not in this section. So I go down to 24. 24 is in this section, so 24 is our GCF number. So far we have a GCF of 24. Now I have to look at the letters. This one has an x, and so does this one. They both have x squared, so that means the smallest exponent is 2. That means we can factor out a GCF of x squared as well. Then we go to y. This 48 has the y, 72 also has the y. The smallest exponent is the 1. That means I can divide both of these by 1y. So I can have 1y as part of our GCF. We go to the z. 48 has a z, 72 has a z. The smallest exponent is the squared, so that means I can divide by z squared. 72 has a w, but 48 does not have a w, therefore it's not common to both of them, so I cannot put it for my GCF. Greatest common factor. So if it doesn't have it in common, you cannot use it. So this is our GCF. Finding the GCF is the first aspect of it. Then what we'll do, once we find the GCF, we'll actually factor it out of the problem. So this is where we're going to factor completely. Always, no matter what, every first step you do is your GCF. So we need to find our GCF of 9n squared and 24n. So if we understand what our GCF is, we have 9 and 24. The GCF of 9 and 24, GCF, is going to be, we know it's 1 times 9 and 3 times 3. So 9 will not go into 24, but 3 will. So we know our GCF has a 3 in it. And now they both have letters. So they have the same letter. That means we can have a GCF of a letter as well. The smallest exponent is the 1, so their GCF is 3n, 1n. We found our GCF just like we did up here, but now is the time where we actually factor it out. Notice that there's no comma in here. This is an actual expression where we have to factor the GCF out of the expression. Factoring is rewriting it as the product. So in order to factor, we divide. To rewrite as a product, that means that you actually divide it. You're doing the inverse operation. So we're going to divide our GCF. So every term, we have to divide our GCF. I'm going to rewrite the problem, 9n squared minus 24n. Now I'm going to take my GCF and I'm going to divide every term by our GCF, which was 3n. Now that 3n is part of our answer, so when we write out our answer, our 3n is going to be on the outside of a parentheses because we know that we can distribute it back through because it was our GCF. GCF will always go on the outside of a parentheses, always. So let's simplify. 9 divided by 3 is 3. N squared divided by n is n. I keep moving. I don't close my parentheses until I have factored out the GCF of every term. So I have minus 24 divided by 3 is 8. And n divided by n is 1, so that's just 8 times 1. The n's will just go away on that one. So that's the end of the terms, so I'm going to close my parentheses. This is us factoring out the GCF. Now this could be the only thing that you're able to do with factoring, and that's perfectly acceptable. If we go to this next one, 4x squared plus 20x minus 12, again the first step is to always factor out your GCF. So our GCF, I'm going to write it off to the side. If we have a 4, a 20, and a 12. We know that 4 is 1 times 4. So 4 goes into 20, and 4 goes into 12. So automatically we have our GCF. I know it can't be anything larger than 4 because 10, which is a factor of 20, 4 cannot be divided by 10. So I know I actually can look at my smaller number to determine what our GCF is. So look at my smaller number, 4. And 4 can go into both 20 and 12. I can divide both of these numbers by 4. So far, our GCF is 4. Now we look at our letters. This one has an x squared. This one has an x, but this one has no x. GCF means greatest common factor again. So common, x is not common to all of the terms. Therefore, we can't use the x as a GCF. It means our GCF is only 4. So I take my original problem, 4x squared plus 20x minus 12, and I have to divide all of these terms by our GCF, which was 4. And again, the GCF will go on the outside of the parentheses. So I know I'm going to have 4 parentheses because that was the GCF. 4 divided by 4 is 1, and I keep the x squared. So 1x squared is just x squared. Positive 20x divided by 4 is a positive 5, and we keep the x. Negative 12 divided by 4 is a negative 3. We're going to close the parentheses because that was the end of the factoring part right here. So then this is where we would look to see if we could factor this further. We still have a remaining 3 terms. We will try and factor this further if possible. I will let you know that this one is not factorable any further. So this one can be boxed up. Number 3, again, we're going to do our GCF. We're going to write out our GCF. You can see that both of these have a number, a 4 and a 2. I like just look at the smaller number, 2. We know that factors of 2 are 1 and 2. The largest one is 2. 4 can be divided by 2, so GCF so far is a 2. These both have letters, and they do have the same letter, so they have a W. And again, we look at the smaller exponent. This has a W to the first power. I can divide this one by 1W. That would be fine. So I have the GCF as 2W. I rewrite the original problem, 4W squared plus 2W, and I divide each term by 2W. Now, if you remember, the GCF will always go on the outside of the parentheses. 4 divided by 2 is 2. W squared divided by W is W. Plus 2W divided by 2W is in fact 1. You cannot leave it as 0. Anything divided by itself is 1. You must write the 1 if you have divided it. Because if we were to redistribute and we didn't have the 1, we would just have 4W squared and that would be it. And we know that we're supposed to have that extra 2W there. So we have to have the 1 so we can show that 2W times 2W is 4W squared, and 2W times 1 is 2W. We've divided it to the end, so now we can close the parentheses. The inside of the parentheses would be what we would try to factor further, and this one will not factor further because it is a linear problem, and we've already factored our GCF. So we can box this up, and this is our final solution. This last one is a bit longer, but only because of the multiple letters. So we still find our GCF like we have been. So our GCF equals. We're going to look at our numbers. We have 18, 12, and 24. We're going to focus on the 12 because it's the smaller number. Start with 1 times 12. So 12 is your largest number. 18 is not divisible by 12, so we know that 12 won't work. We move down with the 12. It was 2 times 6. So we start with 6. 18 can be divided by 6, 12 can be divided by 6, and 24 can be divided by 6. So far our GCF has a 6. Now we look at the letters. We have an M, and M. That means that we can factor out an M. We have an M squared, and M squared. So our GCF has an M squared because the 2 is the smallest exponent. We have an N, and N. That means that we will have an N. We have a 4, 3, and 2. The smallest exponent is the 2, so our GCF will have an N squared with it. So our GCF is 6M squared, N squared. Now we have to divide all of this out because that's what factoring is. We're going to factor the GCF out of it. So we're going to write the original problem, 18M squared n to the 4th minus 12M squared n cubed plus 24M squared n squared. And we're going to divide each of these terms, all 3 of these terms, by 6M squared n squared. 6M squared n squared. We're going to write out our final answer. Now remember, the GCF will go on the outside of the parentheses, so 6M squared n squared, parentheses. 18 divided by 6 is 3. M squared divided by M squared is 1, so that's 3 times 1 stays as 3. Then n to the 4th divided by n squared is going to be n squared because you take 2 away from the 4. Then we're going to have negative 12 divided by 6 is negative 2. m squared divided by m squared, again, is just 1. Then we have n cubed divided by n squared is going to be left with n because we're taking 2 away from the 3. Then we're going to have 24 divided by 6, which is a positive 4. Then we're going to have m squared divided by m squared, which is a 1. N squared divided by n squared, which is also a 1. So that's just 4 times 1 times 1 stays as 4. And that's the end of our expression, so we can close our parentheses. And again, we would look to see inside the parentheses if that could factor further. It will not, so we can go ahead and box this up as our final solution.